Hello and welcome to this video where we are looking at handling questionnaire data, including some early manipulations, and how we take that forward and analysing it using chi-squared. First I wanted to start off with this dummy data set, perfectly applicable for animal scientists, where people have gone to the zoo and have been asked why are they there. So I've set the data up for GENSTAT, so I have my different independent variables, gender, with different codings. I've got an age factor, I've got a marital status factor, and then I have 5 questions that I've just made up on the reasons why they go there. So they can answer yes or no to any of these questions. So do they go there to play? Do they go there to see the animals? Do they go there for conservation reasons, education reasons, anything else? And if they do say yes to this one, then they state the answer there in an open question, and then an open question here as well. So I'm going to deal with 2 things. First, what happens if we haven't got enough data and how we combine columns, and second, how we deal with this type of data, the open data, in a brief introduction to coding. So first, we've got this problem that as an afterthought I suddenly thought, actually conservation and education, they're the same thing. I don't want to analyse those separately. I want to analyse people who either said yes to one or both of those columns. I'm sure there's clever if statements in Excel that makes it a little easier, but here I'm going to simply combine it into a separate reason. I'm going to make that as reason 4a, and this is going to be conservation and education here. So if they said yes to either of those questions, I'm going to make that a factor, I'm going to give it a 1. So 0 for the first one. Second one, they said yes to conservation. Third one, they said 0 to both. And here they said yes to one of them, and on both of them, and here we said yes to the other one here. So we have a combined one. This is a particularly useful technique if you are trying to mop up some of the rarer answers, but combine that with your analysis. So you might want to combine, perhaps disagree with strongly disagree in a survey where very few people said one or other of those categories. So that's combining columns, and we simply add an extra column in there that we can analyze later on. Coding is slightly different. Here I have some open questions. Yes, these are fairly simplistic answers, and real life questionnaires are more complex. But here I've got the question, do you like being at the zoo? And my students ask me, how do I analyze these words? And the idea is to extract some of the data from there. So I'm going to set up 3 different types of data extraction. So for the first part, for the question extraction, I'm going to say, do they like going to the zoo because their children like it? If I look at my first answer, I see it is great to bring the children. So they've mentioned that point. In the second one, I have come to see the tigers. They are my favourites. They have not mentioned the children, so nothing for that one. Lovely place to be, well organised and good food. Nothing for that one. I have my gold card for years. Really like new developments and learn new things. Nothing for that one. But perfect place for grandchildren. Boom, we've got that one. What else? Well, I might be interested in their membership. So I'm going to say, have they got a gold card? Do they mention gold card? Do they mention gold card in their open answers? First person says yes, second person says no, no, but the fourth person says yes, and the last one no. And then the last sort of thing I might extract, I might say, do you use the zoo for education? Yes, we've said it earlier on, but we're going to confirm that with a discussion of these open questions. And we could also follow this up by looking at the ones here to look for particular quotations that might support some of our more qualitative analysis later on. So no to the first one, no, no again. The third one talks about learning new things. So we can say yes. And the last one also talks about learning about the animals. So that's a yes. So the coding is about looking at themes within answers and then turning that into more objective data. So that's the coding part of the analysis. Next, let's look at a particular example of how we present this data. So here we have a particular example of a big data set, courtesy of Dr. Sue Judd, ex-Writtle University College, an equine specialist, and she was looking at how we diversify farms into potential equine events. So we'll be looking at these data later on. But I wanted to just have a quick look at this kind of spreadsheet, which is the kind of output you would get from Google Forms or SurveyMonkey or any similar package like that. So each row in this spreadsheet relates to a single questionnaire, single person answering a questionnaire. It's usually given a case ID up front, and every column is a question. So we have a whole series of independent variables here: gender, activity, job, income, age, home, etc., etc. And then we have a whole series of dependent variables. These are the kind of attitude questions that you ask from your participants. So I always show this paper to students. So I think the setup of the tables is particularly nice. So here, this paper is looking at free roaming dogs and cats in central Italy, essentially stray dogs and cats, and public perceptions. So it is quite a big survey, lots of people, and I've always liked how they present a fairly complex data set in a fairly simple manner. So if we go down to their first table, we have both descriptive and chi-squared analysis here, presented in a table. And what I particularly like is that they only try and present one question: are free roaming dogs and cats a problem? On a single table. It makes it nice and clear. So we have the question across the top. In this case it's a no or yes answer, but of course if it was a three-part answer you could have had 3 columns here. And then we have the independent variables: gender, age, marital status, education level. On the handout it runs out there, but notice that this table goes on and on and on and on, and goes on to the next page as well. And then we have the data, and we also have the p-value, which relates to each individual variable. So is there an association between gender and the question? The answer is in the p-value. Is there an association between age and the question? The answer is in the p-value. Actually, I think the table could be simplified a bit further. I think the idea of having both the actual counts here and the percentage of a total figure, this is the margin, this is the total of the row, 24 and 263 is 287, is a bit redundant. Personally, I prefer to see just a percentage here, 8%, 92% of 287, and that would lose all these numbers in the brackets and tidy up the table. I've had a go at tidying it up here. Let's have a look. I'll drag it on. So this would be my preference, with just the percentages and the end value there. And I'm going to show you how to produce a table like this and how to calculate this p-value in the next part of the video. So I'm going back to this big data set on the equine diversification, and we're just going to do one very simple analysis. I'm going to take a particular factor, age, and I'm going to analyze that against one question. So here we've got a number of questions about what was available in the local area. Is your biggest problem unavailable of the countryside, unavailability of equine events, unavailability of a cross-country course, unavailability of indoor facilities. And of course these 4 things are very informative to someone trying to diversify a farm into equine activities. I'm just going to pick one analysis. I'm going to look at age versus the unavailability of the countryside. Now, first things first, to set this up for GENSTAT, I need to make everything a factor. So I can either do it here, so I can make some factors here by just putting an exclamation mark after each one, or if you forget to do that, and I'm going to deliberately forget to do that, I'm going to do that in GENSTAT in a moment. So to get the whole data set, as long as this is the only data available, I click anywhere in the table, anywhere, and I press Ctrl A, and that selects my entire data set. I'm going to copy that, and then I'm going to go to GENSTAT, and as always, spread, new, from clipboard. Here, this is the first set of data coming in. And that's OK. Now you can see where I input the exclamation marks, it's already identified those as factors, but the next columns, because I hadn't identified those as factors and they're not numeric in the responses, then it's by default it's going to label them as text unless I say otherwise. So here I'm going to take these ones, and also these questions, although they were 1-0 answers, I want them to be factors as well. I'm going to take all of those and make them factors. So I could click factor for each one, or I could convert all. And I'm just going to press OK. And it's left a few more complex ones that I'm not going to use as text, but that doesn't matter. The two I'm going to look at is age and unavailability of the countryside. So first up is the table. So I'm going to make the first part of the table, and then I'm going to do the analysis that gives me the p-value afterwards. So I'm going to do the demographics against the unavailability of the countryside. So I go to stats, and this time I'm not going to do a full-on inferential test. I'm going to do summary statistics. I'm going to use the frequency tables, and that's going to generate for each individual item the part of the table that I want. So I'm going to put age in first. It's in alphabetical order, so I'll put age in there, and I'm going to put in UNC-side, the unavailability of the countryside, as the second group. I'm only just going to include those two groups. If I wanted to do other demographics, I would replace age with those other demographics here. So I want to put a tick in this box, make table as percentage of age margin. We'll see what that means in a minute. And I'm going to click set margin, and I'm going to run. We go to this output, and we've got two tables here to look at. So the first one is based on just the counts. So this is a really nice way of summarizing the data first of all. So in the 10 to 14 age category, 63 people said that actually unavailability of the countryside wasn't a problem, but 21 of the people said it was a problem. And here's my total of 84. If I go back to the table we were making before, you can see the equivalent: no, yes, n, and our variable. And you can see that GENSTAT has already laid it all out for us in the right format. Actually, what I prefer is to ignore this one and go straight to this one, where we have the percentages. So 63 out of 84 is 75%. So 75% of 84 versus 25% of 84. And of course these ones are far more intuitive to compare in terms of the percentages. Okay. So next I want to produce that table. If I just highlight the data from GENSTAT, I just need the second table. I can right click and copy that. And then I could put it straight into Word, but actually I find it easier to just first put it into Excel. Boom. Where'd it go? Put it into Excel. And it's already in columns and row format. If you put it straight into Word, it tries to space it all out using tab markers and paragraph returns, and it's a bit messy. Notice here, Excel's little flaws is it tries to be too clever. In my 10 to 14 age group, Excel thinks, oh, you're trying to put in a date. October the 14th. I don't want a date there. So if I put 10 minus 14, it will do that again. So I need to put in an apostrophe, which will force Excel to accept that as text. The apostrophe will disappear, and it'll just have that text label and a little green thing to remind me. So I'm going to take these data, and remember I could copy and paste all the other analyses underneath this, but I copy that and I put it into Word, and I'm well on the way to having a table. Now you're going to have to forgive this next part, but I'm going to take you through making a table from scratch and all the little problems I found along the way. So first up, I have this table here, but actually it's sometimes good to see those grid lines. I actually turn them off for the purposes of the videos, but if I click on the table, I go to Layout, up here is View Grid Lines, and if I click there, boom, then I can see what I'm doing in the table, and I can see that everything is aligned to the right and not the center, and various other things. So I'm going to try and remake that table we saw from the free Roaming Dogs and Cats paper. So first I'm going to make the columns a bit wider. I'm going to make this column wider. I'm going to delete these top parts that I don't really want. Boom. I'll put something else in there. And I'm going to make these columns. I need to add a column here that's going to be for my p-value. So I click here, and I'm going to right click, insert column to the right. So I'm going to put my p-value in that column. Now I'm going to give my table a bit of width. There's plenty of space on the side, so I'm going to move that line over there. And if I just make that one a bit wider, if I select all those columns, so at the top where that black arrow is, I'm going to select all the columns and then right click. I'm going to distribute these columns evenly. It's just going to be nice and tidy then. There we go. That's fine. So first I'm going to include my question. And my question is unavailability of the countryside a problem to you? Question mark. And I want to just spread that over these three questions, so three columns. So right click, I'm going to merge those cells, and that's nice and tidy. So this column was no, and the number 75 is the percentage. So I haven't got N and percentage like in the free Roaming Dogs and Cats paper. I've just got no and percentage, and this one is yes, and again percentage. And this one is my total, and that is actually going to be big N because it's the whole row. And this last one is going to be my p-value. And my p-value comes from chi-squared. Now let's see where we can find chi-squared in Word. And it's not quite as straightforward as I thought it was going to be. So we're going to put p-value, and here we're going to put something into Word. So we're going to insert something, and the answer is insert symbol. So we're going to go to symbol, and then let's pretend that's not there. More symbols, boom, and here. Well, now you normally start with whatever you're working in. So I'm going to reset it to where we were. So say it's Calibri, and you usually start on basic Latin. Okay? Where you find chi-square is, as you might expect, in Greek and Coptic. Greek is a Greek letter. So say you're working in Arial, which is what lots of people write in. You scroll down here, you'll find the Greek letters, and there you have small lowercase chi and uppercase chi, which is all very well, but it's not a very tidy one actually. And I think the one from, if you change the font set to Times New Roman, which is in here, forgive me, looks a lot better with the curl and the straight line. So we're going to take that, I'm going to insert that, close, so that's there. I need to put a superscript 2 there, so I go to the home menu, go to superscript, which is this one, boom, and put in a 2, turn that off again, so my bracket isn't superscript, and finish that there. That's fine. So I'm going to make all these centered on the columns. That's it. It all looks underlined, but I think it's going to be okay. So the sharp-eyed amongst you will notice one thing that's still wrong, that I have an inconsistent number of decimal places, and that is a problem. So here, this shouldn't be 75, when we've got 71.1. One decimal place is good for the percentages, so I'm going to make that 75.0. I'm going to make this one 25.0 here. And then it leaves me to do one thing for this table, apart from the following analysis, and that's have these lines. So there's no vertical lines on tables. I'll put a top border here, and then just to match the table, you can have a look at the Italian paper if you like. They put a bottom border under that, and then they put a bottom border under that. And if I was to add some more data here, I put it underneath, put a space underneath, and you might want to make that bold, and you might put it in italics or something so it stands out from the data. You could insert some more columns, some more rows, etc., etc. Add some more rows like this. And then at the bottom of the table, and only at the bottom of the table, you put another line. Okay. So we have that. So that's all ready to go. The only thing missing is this p-value just here. So let's go and make that. So here we are back in GENSTAT, and here we're looking back at the big data set. Remember that we've got factors for every question. Factor, factor, factor. These should be factors if we're going to include them. I can just right click this one to make it a factor. Right click, convert to factor. Right click, convert to factor. And we have a sea of pink, and that's what you want for this kind of analysis, of all to be factors. In another video, I show how we use chi-square to analyze contingency table type data, where we looked at different behavior data or different preferences, that kind of thing. And it's the same here. We're going to go to stats, go to statistical tests, and back to contingency tables for chi-square. Select this one. But while before we had a single variant with grouping factors, where we looked at enclosure use in those Sitatunga deer, here we're going to go for row and column factors. So we've got no data appearing yet until we click in the row here. So row factor, I'm going to click there, and here I'm going to add in age, because that is the rows in our table. Double click there. Column factor, I want to look at that unavailability of the countryside. There it is. We don't need to save the table anywhere. I'm going to just run that. It goes to the output, and straight away it gives us our p-value. P equals 0.377. So I can simply take that, I can right click and copy it, and I can go back to my table in Word, and I can put that p-value just there. And essentially that's the whole analysis. In the other video looking at chi-square, we did lots of post hoc analysis as well to see where the differences lay. You can do with that in here, but actually when we do questionnaire analysis, it tends to be a little more superficial, and that is the complete presentation there. Of course, you need a text description of this as well, but essentially all the detail you need for your thesis is on that table, apart from a table title, of course. Let's add that. So finally, we've added a table title, chi-square analyses. Assist for one, but we're going to add some more underneath. Chi-square analyses for respondents who indicated that unavailability of the countryside was or was not a problem. Makes a nice title, it captures all the things. I've just noticed one last thing, is that when you get your data from GENSTAT, GENSTAT sorts everything for you. So while our categories are all neatly ordered anyway, because they're numerically, under 9 has appeared here because it's U, under 9. So actually that should appear at the top. So I'm going to add a row in here, and I'm going to transfer these numbers up to here. And now that will make sense. So GENSTAT has sorted it, but you might need to check that your codes make sense. No difficulties in swapping these lines around if you want to. Now there's a complete analysis, and hopefully that takes you a long way forward to analysing your questionnaires. Thank you for watching.